My name is Marcos Placona, and I'm a developer evangelist for a company called Twilio. I work for Twilio as a developer evangelist. There's a bunch of information about me on the screen. You'll find my GitHub account. I also run a website called androidsecurity.info. Most of the information I'm going to tell you about today, you will find some blog posts about it on this website. So just out of interest, so I just have a few questions. Who's not familiar with Twilio here? Cool. So Twilio is a communications API that helps developers like yourselves adding things like messaging, voice, so telephone calls, SMS messages, video, and security into your applications. We have a bunch of APIs, we have a bunch of SDKs that you can use either on Android or iOS, or you can also use that on the browser. So if you have a need of adding anything like VoIP, for example, or sending SMS messages, you can use Twilio for that. But this is as much as I'm going to talk about Twilio today, okay? Because I'm here to talk about a much more, I feel it's a much more important topic, which is security. How many of you are mobile developers? Okay, and leave your hands up if you are an Android developer. Okay, so I'd say maybe like a quarter of the room Android developer, and I suppose the other ones will be either iOS or maybe building hybrid applications. I am going to be talking to you today about mostly Android, so I'm going to be giving you some Android examples. However, all the stuff I'm going to tell you about also applies to iOS, and some of it applies even to the web. Okay, so even if you're not a mobile developer, there are going to be things here today that will be super interesting for you as well, as a backend developer, for example. But let's get started. So I just want to start with a bit of an announcement here. I am not a hacker, okay? So some of the things you're going to see here today, maybe you will turn out to be a much better hacker than I am. So I'm not here to try and show you how to become a hacker. And most of all, I'm not here to try and show you how to become a hacker and wear something ridiculous like this. What I am trying to show you is certain ways and certain things you can do to actually protect your applications, okay? So when I started off this journey on security, I knew very little about security. I knew a lot about security from a web point of view, and I knew very little about security from a mobile point of view, which I find that is very normal. Most mobile developers I speak with, they really don't know much about security. So today, I'm going to try and show you some of my learnings, some of those things that I learned throughout the time. The next thing I'm going to tell you is I deeply care about security. Security is now something I think about a lot. I spend a large bunch of my time, if I'm not actually building applications, I spend a large bunch of my time actually trying to hack into applications. I don't try to hack into applications to get bounties. That's not what I'm here for. What I try to do is I try and find exploits in applications, and then I get in touch with the developers to say, hey, I found a problem with your application, and you should go and fix it. Here's what you should do. And this is it. This is the deal, okay? So not trying to get anything out of it, not trying to do anything dodgy. And to my next slides, I want to make sure that you, I just wanted to make sure you read this thing, okay? It's pretty quick and not too long. But the important thing here, okay, so you can skip all of this. The important thing here that you need to know is I haven't really hacked your app. Okay? And I know the title of this talk is I just hacked your app. I have not really hacked your app, and the reason I have to say this is because throughout my journey, throughout my learning process on this, I managed to hack some real apps. And what I found was that if I go on stage and I show the hacks and I show the apps, the real apps I actually hacked, companies tend to get a bit suey. And this is totally a made-up thing, but basically what I'm trying to say is companies will get annoyed if I come on stage and I show you all the things I've been able to do with their apps. So instead, what I'm going to do today is I'm going to show you how I hacked some of my apps. And the one thing you're going to find is that sometimes there will be a very vague resemblance to real apps that you may have used in the past, okay? I'm not naming names. I don't mean to, make any developers feel uncomfortable here. But what I'm trying to do is, there are things that you as a developer can do to actually protect apps. So people like me don't go and hack your applications, okay? And remember, I'm not really a hacker, so I'm not here to do bad things with applications, but there are people out there doing very, very bad things with applications. But let's start from the very beginning, okay? Because some of you told me you're mobile developers, some of you are maybe web developers. I have two characters in this scenario here, and this is to represent what an HTTP request is, okay? So you have a client out there, and you have a server right here. And what happens is the client makes a request to the server to ask for some information. So this could be, for example, a login. This could be list how much money, tell me how much money I have on my account. So that's the idea here, okay? So this is how basic HTTP works. You make a request, the server then gets back to you, right? So I feel like right now everyone is with me, okay? You most certainly have done this thing before. So what happens sometimes, and what happened to the example I just gave you when I was hacking my own application here, is there is a third character that comes up. This third character, I'm trying to represent that with a parrot flag. And what this third character does is, instead of letting you make a request directly to the server, it intercepts your request. And when it does that, it sends that request to the server. So you, as a customer, make a request to the man in the middle. So that's the name of this hack, by the way. The man in the middle makes a request to the server. The server returns, man in the middle gives it back to you. You can't see anything. You're none the wiser in here, because everything is really transparent and happening the way it should be happening. However, this character here now knows everything that you passed, and he knows everything that came from the server as well. So remember, I said this could be maybe a request to your bank. This could be your login. This could be your password. This could be your life insurance. This could be many, many things that now someone here just knows everything about. And why is this important? And what kind of other examples can I give you to show you that this happens all the time? So let's look at another example.
I wanna be the very best.
Who's playing Pokemon Go still? Okay, I still am. And there is one important thing about Pokemon Go, because it was one of the most famous man-in-the-middle attacks. And the reason it was one of the most famous man-in-the-middle attacks was because the motivation. So let me just start again. If you are not playing Pokemon Go, if you never play Pokemon Go, I'll just give you what the idea with this is. You have this application here, you have your own character, and the point of Pokemon Go is you walk around and you catch Pikachus. The more you walk around, the more Pikachus you get, or the more Pokemon you get. There's not only Pikachus, there's more, but the more Pokemons you get, okay? So walking around gives you Pokemons. You need to walk around quite a lot to actually get those Pokemons. So what someone did was, someone realized that there was an API behind it, and every single time you walked around, the application will make a request to the API to say, hey, this person is walking around, let's spawn some Pikachus and some Squirtles and Charmanders because this person is walking around. But walking around is boring, and walking around with your phone is even more boring. So what these people realized was that instead of making people walk around, they realized that they could build something like this. This is not part of the app, okay? So this was injected inside the application. And with this, instead of walking around, you could now press the arrows and your character would walk around. So you would see all of the Pokemons. So the motivation here, and I'm going to be talking about motivation a little later as well, but the motivation here was catching Pokemons. Okay? So there was no real tangible motivation in this case. The motivation was, let's just catch some Pokemons. Now, let's stick to motivation, because I feel like the next one is, at least I would be way more motivated with the next one. Has anyone heard about Kuba Gretzky? Right, so Kuba Gretzky is a Polish developer who realized that he could get free beer by hacking an Android application. So, motivation, right? Pikachu's, beer. Now, the one thing I always like to point out in this picture, so this picture actually came up on the register, and the one thing I always like to point out in this picture, and this is a stock picture, okay, is that the description says, strangely dressed man drinks beer. So, most of you are Polish developers. Do you ever dress like this when you're hacking? Every day, yeah. Okay, so I'm learning new things here. But the way Kuba Gretzky actually managed to hack this application was through loyalty. So as it turns out, here in Poland, last year, there was an application that was very similar to this one that would give you 1 free beer for every 5 beers that you bought. So you would go to a bar, you would show your phone, and you would get a free stamp. So very much like, what happens to Starbucks. When you go to Starbucks and you buy 15 coffees, you get a star for each one of the coffees you buy, and then once you buy 15 coffees, you get a free coffee. In Poland, they did the same. Every 5 beers, you get a free beer. Okay? So, motivation here, right? But let me just tell you a little bit about how this application actually worked and what was actually behind this entire application. There was a loyalty application over there. There was a beacon. And there was here the server. Every single time you went to the bar and you bought a beer, the application will make a request to the beacon. The beacon will then return something to this application. This application would then know and be able to make a request to the server with that something I just mentioned, which we'll see in a bit. Kuba Gretzky then realized that every single time this happened right here, there could have maybe been something he could have done to maybe take advantage of this. So what he did was he installed an HTTP proxy in the middle. So he used the same attack I just told you about. He used the man-in-the-middle attack, and he used an HTTP proxy. So every single time every single time he bought a beer at the bar, and this whole dance here happened, he knew exactly what was being passed. Now, Kuba was presented with some information that looked very much like this. In fact, this is the real thing. This is the real request. So that's an HTTP request. You can see there's a post going on right there. This is probably his user, because he obviously was logged in, and he was making a post to a endpoint. In this post, there was something really interesting. There was an authentication token, which was in plain text. Also, in here, there was information about the beacon. So if Kuba wanted to build his own beacon factory, or he could have cloned this beacon, and then he could have built the same thing inside his house. So every single time he went to the fridge, he got beer, he could use the beacon. So he didn't actually have to go to the bar. But the most important thing is, every single time he ran this thing, he would get an extra point inside the application. So he would get an extra star inside the application. And like I said, every 5 stars gives you 1 free beer. He also found that there were some other promoted products. So it wasn't just about beer. There were things like burgers, for example. Buy 5 burgers, get 1 burger free. But he was only concerned about beer, okay? Like, this was not important to him. Beer was the important thing to him. And sure enough, what Kuba realized was that every single time he made this kind of request with this token, he would get a free beer. So every time, 1 beer, 2 beers, every single time he made a request, he would get 1 free beer. How awesome is this? So there's nothing, I think the only thing that is better than beer is free beer, isn't it? So in fact, what happened was, Kuba got access to an unknown amount of beer. Okay, so no one really knows how much beer Kuba actually got access to. But what Kuba did was, he wrote a blog post about this last year. So as you can see, he wrote a blog post back on the 18th of August. And this could be either two things. This could either be the day when he was really tired of drinking beer. He was like, yeah, I don't want to have this anymore. Like, I had too much beer. Or it could be the day that he said, do you know what, I'm going to tell the world about this. And Kuba was very, he was very honest in this, but he was also very careful because he didn't name the app. He wasn't trying, he was obviously making profit out of it by drinking free beer, but he wasn't trying to get anyone else to do it. He was basically just exposing an exploit. Now, the other important thing to see on these slides here is, this was the day, if you can't see from the back, it says the 18th of August. This was the day when he published, or he posted about this hack. The last time he blogged, you can't see it at the bottom, but the last time he blogged was in July, and then the last time he blogged was in June, which tells me he used to be a quite frequent blogger. He would blog maybe once a month. He hasn't blogged since this. Either he's drinking beer right now and he doesn't have any time to blog, or he got in trouble. So if anyone here knows Kuba Gretzky, and please just tell me if he's okay. Now, so we looked at this example, and this is more like a real-life example because we looked at myself hacking my own application, then we looked at Pokemon Go. This is more of a real-life example. So what could the developers have done to maybe stop this from happening? So what could they do to stop these kind of things from happening? There are a few things that I'm going to talk about them, and I'm going to show you some codes as well. One of the first ones, which is a really simple thing, is they could have encrypted the values. Like, remember when I showed you a slide that had every single value in plain text? They could have encrypted those values. There was a talk about encryption earlier today where the speaker was actually talking about ways you can encrypt values and obviously how each encryption method can be broken. So there's no silver bullet here, but obviously when you're trying to hack something or when you're trying to look at something like this, for example, and you find that everything is in plain text, it just makes your life so much easier. You want to carry on. Because had these values been encrypted, maybe Kuba would have stopped and said, okay, so this is beyond my knowledge, so I'm going to stop right here. Now, encrypting values, there are many, many ways you can do encryption. So I'm going to show you one example here. So if you're an Android developer, you will be familiar with this. So this is a Gradle dependency. And what you do is you have a way, so this is a library that you can use to encrypt a value. And there's also a way you can decrypt this, which is here. So not super complex. This is not complicated stuff, okay? So encrypting values, if a developer tells you, or if you tell yourself, I'm not going to encrypt my values because it's going to be too much work, it's not, it's this. So encrypting is easy. Decrypting might not be as easy, but we have an example here of decryption. Now, the one thing I want to point out to you is I am encrypting a value here, and I actually have a password, which is what I'm using to encrypt. And this is something you should not do. And I'm going to tell you why you shouldn't do that, and I'm going to tell you about ways you can actually hide those values, either inside your application or coming from elsewhere. But the reason I'm saying you shouldn't have these values inside your application is because if you are a developer like myself, you will know that eventually your keys are going to end up in GitHub. I've done that so many times, and there's this sense of desperation, like as soon as you make a push, as soon as you push some code to GitHub, you go, oh, my keys. And the thing about pushing keys to GitHub is it's really hard to get them out. So GitHub will have some pre-commit hooks that will tell you when you try to do that, and they will try to stop you from doing it if your keys are called authentication key, for example, or if they are in a specific pattern, then GitHub will stop you from doing that. If your key is something like I love cats, then GitHub will not stop you. And then your keys are going to end up there, and deleting a commit and deleting all the history from GitHub is really hard. So most times this happened to me in the past. I just went and made that repository private and created a new one because I had to make sure things disappeared quickly. So this is one example of a guy called Look who, yeah, for some reason you can't see the bottom of it. I think it's the resolution. But there was a guy called Look who made a mistake and committed his keys to GitHub. Those were his AWS keys. So as it turns out, there are people looking for things like authentication token, key, password, username. So they're looking for those kind of names, those kind of variables. And when they find those things, they try and do other things with it. And what happens in this example here, as you can see right in the bottom, is Luke was presented with a bill of over $3,000 when he committed his keys to GitHub for 20 minutes. So it took him 20 minutes to realize that he had made a mistake, and then he just went and deleted his repository. In 20 minutes, his bill went from nothing to over $3,000. That's an expensive mistake, isn't it? Especially for just 20 minutes. Luke was lucky enough because, so this was AWS, and basically what happens is, the story with this is, if you commit an AWS key to GitHub, people will find this, and what they do is they start spinning up new VMs to mine Bitcoins. And this is why it gets really expensive really quickly, because mining Bitcoins, there's a lot of processing going on, and you need to have some really strong VMs so you can actually mine Bitcoins. So this is what people do, okay? So there's a bunch of people doing that right now. And he was presented with that bill. He got in touch with Amazon. Amazon said, you need to try and refresh your key. Most APIs will offer you a key, they offer you a way to refresh. He clicked on refresh, and his bill was still going up. So I think it went up. So he said $3,000 there. I think it went up to like $3,500, even after he had refreshed his key. So as it turns out, Amazon had a bug where when you refreshed your key, it would still stay in cache. So it wouldn't automatically, it wouldn't immediately disappear. He was very lucky. He found this bug, and he was very lucky because Amazon says, okay, you found the bug. We know this happens, so you don't have to pay the bill. So yeah, expensive mistake that could have been avoided by things like not pushing your keys to GitHub. Now, what is the next thing that the application developers could have done? They could have used security features. So remember when I said there was information about the iBeacon on that payload on the post request? If you're using something like an iBeacon, for example, try and see if there are any security features that you can use. Because cloning an iBeacon is very easy. You only need 2 pieces of information. But if you are using one of those, you should look at things like, how can I secure this? And as it turns out, you can secure an iBeacon. They're not going to be massively secure, okay? You shouldn't be using those for banking transactions. But there are ways you can secure. And obviously, this wasn't in place, so Luke got access to, Kuba got access to basically everything. How many people know about certificate pinning here? Not many, or not enough. Certificate pinning, the premise with certificate pinning is you have your SSL certificate and you have your application. You can now bind those 2 together. So I can say that only my application can talk to my website, and I can say that only my website can talk to my application. So if anyone else tries to do a man-in-the-middle hack on me to try and spoof my certificate, for example, certificate pinning will stop that. And the way certificate pinning works is, if you are an Android developer, this is the kind of thing you would do. The way you would do that is you have a library, which I think most Android developers use this library for HTTP requests. It's called OKHTTP. You have your public object. So this is your host. Then you basically bind your application to your certificate key. And once you bind that, you just create a pinner. And that's you saying, right, so from now on, every single time someone tries to make a request to my server, or someone tries to do a man-in-the-middle hack through my application, I will stop them because they won't be able to spoof my certificate. So there's a pain with certificate pinning, which is every single time a certificate authority changes your certificate, you will need to change this. And obviously, this is in your application. There are ways you can not have to do that, and we'll get to it in just a bit. Now, the last thing on the stops is do not trust the device, okay? And I say do not trust the device because there's something that happens quite a lot, which is people will use tools like this to decompile your APK. So obviously, when I say do not trust the device, I'm saying someone can actually just get your APK, so just get your application from the device, and this is the same for iOS. It's either APK or IPA. Someone can actually get this from the device, and they can decompile your application. And when they decompile your application, it's really funny, because I used to think that decompiling was this super complex thing, and there was a lot involved in it. And as it turns out, decompiling an application is really easy. This is a free tool. It's open source. This is not an illegal tool I'm showing you. This is on GitHub, and the reason most developers use that is because they want to decompile their own applications to see what kind of information they're actually showing. Now, how long does it take to decompile an application? It's basically that. So APK2D, and boom, it's decoding and decompiling. That's it. So I decompiled an application. Now I have access to files inside this application. And what I'm doing at the very bottom there, if you can't see, is I'm searching my application for things like auth, key, password, user. And sure enough, when I do that, I find things. I didn't have to do anything special here. It was all inside the application. Like, this is a free tool. You can do that to your own apps. You can see what kind of things they're exposing. And I can very much guarantee that if some of this stuff is new to you, you are doing these very things. You're actually exposing yourself. But we talked about not storing things like this inside your application. Because in this example, I had an API password and I had an API username inside my application. And I'm here and I'm telling you, don't store those things inside your application. And most likely you're going to get back to me and say, but I need to have some magic strings. Like, I have APIs I need to access. I have things I need to get data from. So what do I do? And there are a few options. One of the options is encrypt those keys. If you have keys inside your application, make sure that you encrypt them. Honestly, I don't care how you're going to encrypt it or with what kind of encryption algorithm you're going to use to encrypt that. Because some encryption is better than no encryption. Even if you base 64 encode this thing, some encryption is way better than not having anything. So the fact that someone can go into my application, open it, and get my keys and do stuff without being a hacker sounds really dangerous to me. So if you can do things like encrypting it, that's great. If you can use a strong encryption algorithm, that's much better. But if you can't, if Even if you just do base 64, some encryption is better than no encryption. Now, the next thing you can do is you can actually get your keys from a server you own. So instead of having keys like I had on my application, you can actually make an HTTP request to your server. So remember I said certificate pinning, so now only you can make requests to that server. If you have something like this, you can then start getting the keys from the server instead. And this is one of the ways I like to do it, because if my keys change, for example, it's much easier for me to just go and get them from the server. It's much easier for me to have them on a database that I can just go and change. I can have like a UI to change those things, and I don't need to change my app. Because the important thing is, like, every single time you deploy a new version of your app, people will need to download it. Obviously, if your keys change, if they don't download the latest version, it means they won't be able to access your app anymore. So getting them from a server, make sure that your keys are fresh whenever they need to be rotated. Now, there's another way you can do that, and this other way is, it became my favorite way, because it's the one that I think is the least hackable way, or it's the hardest one to break, which is you can actually store those things on the NDK. Now, if you're an Android developer, you know that the NDK is basically the lower level of libraries you can write. So this is the native development kit. So that's the lowest level you can write things in Android. And what you can do, I'm basically talking about C++ here. And what you will do is, you will build a library that actually holds your keys for you, okay? The drawback of doing it this way is, every single time you update your keys, you will need to go and update your library. But what happens is, when you decompile an application that has stuff in the NDK, so keys on the NDK, for example, when you look at the libraries, they look like nothing because they don't get decompiled. So what you're going to end up with is you're going to end up with a massive binary file that, yes, if you open with a hex editor, for example, and you're really good at it, you can find things in there. But again, it's just another layer of protection. And we're talking about layers here. Like, I don't want to disappoint you, but I won't tell you about a silver bullet way that you can protect applications. I'm going to tell you about layers you can build around your application to make them more secure. But there's no silver bullet way. If anyone wants to hack you, they will hack you. It's just that we're trying to make it way more secure. Now, what are the things? Because I told you about what developers could have done to stop a hack. But the thing is, when you're trying to stop a hack, you are pretty much screwed already because you're trying to stop it. So someone has been messing with your application. So I want to talk about some things that you as a developer can do proactively to not allow people to mess with your applications. There are a few things I want to talk about. One of them is thumbprint detection. And I'm always amazed by this one because a lot of people or a lot of mobile developers don't know that you can actually have thumbprint detection in your apps. And when I say thumbprint detection, what I mean is if someone decompiles your application and tries to recompile it, there's ways you can know that. And I find this one is really interesting, and I find it really important as well because it at least gives you a chance to try and do something about it. So, talking about thumbprint detection, I have a code sample here, which basically is checking for two things. The first thing is, it's checking if my application is in one of those two markets. Sorry, no, it's checking if my application has not been renamed. That's the first thing, okay? And I'm going to show you an example of applications being renamed as well, which is quite scary. The second thing it's doing is it is checking whether my application has been renamed. So it's checking, it is checking whether my application has been moved. So it's checking, is my application being installed from Google? Is my application being installed from Amazon? So what you can do in this case is, if someone downloads your APK, recompiles it, and changes it, and moves it to a different store, you can at least tell your user, like, oh, I'm not responsible for this thing. Like, this has been recompiled. This is coming from a source that I don't trust. And you shouldn't trust them either. In this case, I'm using the Android store and I'm using the Amazon store. If you use more stores, then you can just add their runtimes in here, and that's it. So it's that simple. Check for your application signature. This is another one that is it's another one I really like. Every single time you publish your application, every single time you release an application, a signature is generated. So this is the fingerprint of your application. And as long as you don't rename your application, or as long as you don't change your signing certificates, so these are like the P12 files you have, as long as you don't change those things, the signature will always be the same. Which now means if someone was to download, decompile, and recompile the application, because they'll be using a different certificate, a different signing certificate, the signature will be different. Now, checking for signature is this, basically. And by the way, I'm going to be publishing those slides later, so you don't need to take pictures or anything, because they'll be on Twitter. But what I'm doing here is I know what my signature is, and I'm basically checking, okay, is this valid? Is this application using my signature? If it's not, I can do something. So it failed. So I can at least tell the user, this is not my application. And the reason why people do that, the reason why people move applications, and the reason why they rename it, is if you have any way of making money out of your applications, such as if you're using ads, for example, what people will do is they'll change the keys for the ads to be their keys. So now your application is out there, and people are making money every single time someone opens it. Okay? And obviously, if they publish it to a different market, you can see where I'm going with this. Now, does that actually happen? Like, do applications get renamed, and do applications get moved? So this is a search result for my app was copied Android. Okay? So this is a Google search result. It is a search result I did today, so I just keep on updating these slides because the number here keeps on growing. And if you can't see the number is over 4 million people actually asking this question. Over 4 million people have issues like, my app has been copied, what to do when someone clones your app? So there's people talking about this, and this happens all the time. And it happens for, like, you don't need to have an application that is super famous that someone's going to go through the trouble of copying it. There are bots out there that download your APKs, rename them, or move them to a different place, and change certain things in your apps. This happened to me a few times, and it's really funny when I find them because I'm happy to not make any money out of my apps, so I'm okay with this. But I find it really funny because they always add some comments to it. There's always like a bunch of things they add. There are going to be times where they add some really like creepy stuff. For example, they change the permissions your app requests, so now they can do other things. Like they can make, it's the famous flashlights application that sends information about you and all that creepy stuff. Check for rooted device. Checking for rooted device is, I think it's my all-time favorite, but I feel like I should also give you some backgrounds on this, and I say on this one, just make sure you're careful about checking for rooted devices. Checking for rooted devices is this easy, okay? So it's not hard at all. Basically, a rooted device has an executable that is called SU. And SU, basically, if you are a Linux user, SU basically makes you super user. Rooted devices will have this executable, and all you have to do is you try and execute it. And if it works, that device is rooted. If it doesn't, then the device is not rooted. Now, the reason I say be careful with checking for rooted devices is, first, there are ways you can hide the fact that a device is rooted. So there are ways you can literally hide the SU executable and have it in a different place and only move it when you need it. So that's the first reason you should be careful about it. And the second reason is, do you really care that a device is rooted? And this is one important question you should try and answer yourself. Because if you're running a banking application, for example, then yes, you don't want that device to be rooted because people can do bad things with your banking application. If you have a wallpapers application and it's free, do you really care that the device is rooted? Probably not. So it's the one thing that is important. Make sure that if you're making that decision, if you want to do that, if you want to check that a device is rooted, make sure that you're making the right decision. Because there are loads of rooted devices out there. Some devices, they come out of the factory already rooted. And in that case, do you want to stop people from using your application? So it's one decision that you need to make, okay? Now, if you do decide that rooted devices are okay to use your application, there's one thing you need to look out for. And this one thing is a framework called Exposed. Who's heard about Exposed? Cool. So Exposed is basically a framework that you can install in your Android device, and it gives you access to a lot more inside your device. And there's one thing, well, there are many things that are dangerous here, okay? Because you can literally break your device if you do the wrong things here. Much like you can do with a Linux box, for example, if you delete stuff that you shouldn't delete. But there's one thing on Exposed which a lot of people use, and it's especially very used by hackers, which is called hooking. And when you do hooking, the interesting thing about hooking is, the premise with hooking is you can now listen to when a method is actually called inside one application. And when that method is called, you get a notification and you can do something about it. So Exposed has an API. And as a developer, you can use that API to do certain things when certain applications run. So one example of it is we have the system UI here. So we're basically listening to every single time the clock updates. So we're looking at the system UI, and every single time the clock updates, we're not trying to do anything horrible here. But imagine what could be done. So every single time it updates, we just set some text. And we set some colors, and we're setting a smiley face there. So we're not doing anything creepy. But imagine that if you can do this with the system UI, with this package here, you can do this with anything else. So if you do decide that it's okay for people to have a rooted device and still use your application, the one thing I will look out for is if they are using Exposed, and even though you allow rooted devices, make sure that you block Exposed. And there are ways you can block Exposed as well. They keep on getting clever about this, but the whole idea with Exposed is a phone will have a jar file in there. So Exposed injects a jar file into your application, and when it injects this jar file, you can actually detect that. So just to kind of give you an example, if you run Twitter on your phone, if you have the Twitter app on your phone, Twitter runs on a rooted device, okay? Twitter does not run on Exposed. And obviously, because Twitter has information about you, Twitter has information about your token that you use to authenticate, so Twitter does not run on Exposed. And it's the same case with things like Snapchat, for example, so there are ways you can stop that. And I feel like if you do make a decision of sticking with rooted devices, fine. Exposed, I would block it. I don't, unless you actually want to play with it, I would block that, because you can literally do anything with it. The next thing here, so it's not the last thing, there's one more, but the next thing here is check for Emulator. I can't really find a reason that any of my apps, obviously outside of development, I can't find a reason for any of my apps to run on an emulator. Like, there's no reason. Like, they shouldn't run on an emulator. And as it turns out, when you look at the number of applications hacked, most of them are actually hacked on an emulator. Because it's the easiest thing to do, isn't it? It's like you get an APK, you drop it inside your emulator, and the application's running. You don't need a phone. The emulator is automatically rooted. So super easy. Check for emulator. Checking for emulator is as easy as this. So you're basically looking at the fingerprint, and if it says generic, you're talking about the Android emulator. If it says GD Motion, it's a different emulator. So there are a few different emulators you should look for. But in general, I think that my applications, unless I'm actually actively working on them, unless I'm actually building them, they should not run on an emulator. And the last thing on this list is check if the application is debuggable. And that's a funny one because we're talking about APKs. So we're talking about APKs or IPAs that have been released. So theoretically, you built your application, you put it on the store, and every single time you sign your application is no longer debuggable. So any kind of debugging things you have in your application, they shouldn't work anymore because your application is now in release mode. Now, the most interesting thing I found was that, so first I'm going to show you how to check that. So you just check for flag debuggable. Very easy, okay? In that way, you can make a decision like, okay, so is my application in debug mode? Yes, so no, like you can't use my application. But the most interesting thing I found about applications being in debug mode is that they can be in debug mode even when they are in release mode. And I know this sounds complicated, but I'll just show you an example of how you can actually do that. So I have an application here, which I decompiled, and I'm changing one parameter on my manifest, which is Android debuggable true. Now my application is in debug mode. So every single log and every single thing that comes out of my application is now visible if anyone manages to run it on a phone, for example. So they decompile and recompile it, and now my application is debuggable. That's a bit ridiculous, isn't it? Now, this is the point where most people tell me, well, I'm actually unsure, I'm confused, I don't know how to do, I don't know where to go with this. Like, you just told me about a bunch of things, and I really don't know what to do. Like, I really don't know where to start. I'm not doing any of those things, so help me out. There's a few things, I think, if you don't have any of these like security measures in your application, there's a few things you can look at. The first one is look at applications like ProGuard and Dexguard. ProGuards and Dexguards, they're built by the same company, and as you can see, they're just like an upside-down logo. But the thing about ProGuards is actually installed by default. So if you're an Android developer, you're running Android Studio, every time you create a new application, so every time you start a new project, ProGuards is installed. And what ProGuards does is it does name obfuscation for you. It does code optimization. It removes redundant code. And removing redundant code also means that all of those logs that you left in there will disappear because they're redundant. They shouldn't run when your application is in release mode. And this one is important because if someone changes it to debug, they'll be able to see your logs. Name obfuscation is also important because, you may call your method get user account, and this is going to change your method to banana. And that's going to be way less readable. Dexguard is the counterpart of it. Dexguard, as you can see, it does way more. So it does like class encryption, for example. So you're now not only doing obfuscation, but you are encrypting your classes. It does string encryption. It does certificate checks for you. So it checks for certificate pinning. It checks that the certificates are actually valid. So if you're using certificate pinning, it will check that the certificates are valid. Debug detection, emulate detection. So it does a bunch of things for you. And all you need is to have that installed. Now, obviously you're guessing, well, yeah, this one is way better than this one. And obviously that's because that one is free and that one costs money. So if you are running an application that actually requires all these kind of security features and you don't want to go and build them yourself, because I told you about ways you can do some of those things already. If you don't want to do them yourself, then you can always look at the paid version. The paid version is a bit weird. I don't know if anyone here is using Dexguard, but the paid version has a weird, they have a weird subscription model because it starts at something like 4,000 euros, and then as you get more users, the price goes up. It's a really good thing. Like, this is really amazing, but it costs a lot of money. So it's just one thing for you to know. Now, for the free options, you can look at things like SafetyNet API, for example. And SafetyNet API is a free API by Google, and it's very actively maintained by Google. It checks for things like, is this device compatible? Is this device rooted? So talking about compatibility, it will check for things like, is this device compatible with the Play Store? If it's not, you now can make a decision because you know that this device isn't a device that maybe you want to trust. Or is the device rooted? And then again, this is not going to stop anyone. Like, you get to make a decision at this point. It's like, okay, so Google are telling me this device is rooted. Should I do something about it? Should I not do anything about it? But now you get the choice. Now you can make a choice whether you do anything or not. The reason I think this is really cool, and the reason I think this is better than just checking if the device is rooted with code, is because, like I said, there are ways you can hide the facts that you rooted. And because Google are actively working on this, they have like way better knowledge and way better ways of finding if that device is rooted because there's some machine learning on the background as well. So they probably know more about that device than you will be able to know. Now, the other thing you can look at is implement network security configuration. So this is yet another free API by Google. And I know I talked about Dexguard and Google quite a lot. I don't work for either of them. But this is yet another free API by Google. And it does certain things for you which I like. So it does certificate pinning for you. Okay, so the code I actually showed you to help you do certificate pinning, this thing does it for you when you configure it. It does debug overrides. So even if your application gets changed to debug mode equals true, this thing overrides it and it marks it as false. And you change it to try and run it, and then it overrides again. So that's a pretty good way of not having your application in debug mode. There is one limitation with it, which is it only works from Android N and above. We are on Android O right now, which is like the super latest version of Android, and N is very new as well. So that's one limitation. If you're building applications to run on Android N and above, then this is fine. If not, then there is an alternative, which is a backport a guy called Mark Murphy wrote. And basically what that does is it makes this API run on Android 4.2 and above. It's not supported by Google, it's just a backport. But it helps you using this thing. Now, I just want to move on. Again, all these slides are going to be published. I just want to move on to kind of a closing here because I talked about many things. I talked about many ways things can be hacked and things can be stopped. But there's one message I want to leave with you, which is like, don't trust everything you see. Okay? Because not everything out there is what it looks like. Right, so obviously I have been talking about some ways you can stop people from hacking you. I've been talking about some ways, you can try and be proactive about it. But it's worth thinking that not everything you see is the way it is. You might not think a device is rooted than it is. So just be very careful and be very aware that things, people are out there to try and get you. Because when it comes to safety, you need to make sure you protect yourself. With that, I have been Marcus Placona. There's all my information over there, my email, my GitHub, and my website. If you have any questions, you can come and find me later. Thank you very much.